How we doing, everybody? This is That Our Nerd coming at you with a quick video on how to do a confidence interval using the t-distribution. So just to jump right in, a researcher measured nitrous oxide emissions of 18 randomly selected diesel trucks. The average emission for the sample was 0.938 ppm with a standard deviation of 0.102. We want to find an 80% confidence interval for the mean emissions for all standard or for all diesel trucks, right? So we took a sample of 18. Let's write this stuff down. Well, for a confidence interval, what we're going to want to do is we take our sample average, which is x bar. We're going to do plus or minus our t critical value, degrees of freedom n minus 1. And then we're going to multiply that by our standard deviation over the square root of n. Right, so I'm sure you know what these confidence intervals are, but if we look at this, that chunk here is called our margin of error. Right, so everything after our plus or minus is the margin of error. And this we refer to as the standard error. All right, so those are kind of the chunks that make up the confidence interval. This is obviously our sample mean. All right, so let's write down from our little short novel that we wrote up there. We're looking at 18 different trucks, right? So that's our sample size. So n is equal to 18. The degrees of freedom for the t-distribution we find just by taking sample size minus 1, right? So n minus 1 is 17. All right, let's see. X bar is our sample mean, which is 0.938. And then our standard deviation is 0.102. All right, so pretty much the only thing we need left is our t critical value, right? And if we look at alpha, we're doing an 80% confidence interval. So to get alpha, we do 1 minus 0.8, right? 1 minus whatever level of confidence that we're doing, which is 0.2. And then to look it up on the table, we're going to want to do alpha over 2. So do 0.2 divided by 2, which is 0.1. And then the way that I look it up is on a table. You might do it on a calculator or something else, so you can skip ahead a little if you don't want to look at this. But we're going to go look at the table with 17 degrees of freedom, and the area in the tail is 0.1. So we will come over to our table, our t table, and we're going to look at 0.1, which is right there on the end. We're going to come down to 17 degrees of freedom, and our critical value is going to be 1.333. That's a lot of threes, if you ask me. So our t critical value is 1.333. All right, so that's the hard part. Once we have everything listed, I mean, it's cake. We're just plugging things in now, right? So x bar is 0.938. We're going to do a plus or minus our t critical value multiplied by our standard deviation over the square root of n, which is 18. All right, I will plug in here 0.938 minus 1.333 times 0.102 over the square root. Oh, dang it. Press the wrong one. Square root of 18. All right, so the lower end is 0.906. And if we look at the higher end, we switch our subtraction to addition. We're going to be at 0.970. All right. If we wanted to interpret this, we'd say we are 80, since we did an 80% one, we're 80% confident that the average, I should probably write better, I think. Let's write more clear. That's my goal for the rest of this one. The average emissions for diesel trucks is between 0.906 and 0.970. All right, there it is. Confidence intervals. Super easy. Nothing crazy. Very nice. Very nice. Yeah, that's it. If you enjoyed this video, make sure to press like so other people can find it. If you have questions, leave them in the comments below. Subscribe for the best stat content and our content if you're into that. Available on YouTube. Thanks for your time. We'll catch you on the flip side.